Section 5.3, which is what we're working on now, takes the skill of 5.2, and you're basically going in reverse. So what you have now is you have the percentile. You know what percent fell below a certain value. So that's what a percentile ranking means. A percentile ranking of 95% means I know 95%, I know the percent of people that are below a certain point. I want to know what's the point. So working backwards, I now have the area. If you change your percent to a decimal, I have the area of 0.95. I need to know what z-score goes with that. And once I have a z-score, I can work my way backwards through the z-score formula and get back to the real life value. In this case, the real life braking distance. You're going to use technology to do this for you. I just wanted to show you what the process was. So what your calculator needs to know is it needs to know, first of all, what percentile ranking are you working with? So for this question, we're working with 0.95. 95 percentile. And then it needs to know, so that it can calculate kind of the reverse z-score, it needs to know what's the mean, and then it needs to know what's the standard deviation, since those are both part of the z-score formula. So you hit your vars key, actually you hit your second and your vars key in your calculator to get to those normal functions, and you had normal PDF, and then you had normal CDF, and the CDF is what we previously used. And underneath that, you will see something called INV, inv, norm. What that means is inverse. We're going in reverse. And that's what we want for this type of problem. When we have a percentile ranking, and we want to get back to the real life value, in this case, I want a distance, you're going to do inverse norm. And so I've got to give my calculator those two values that I just talked about. Actually, 3 values. So the first thing it wants to know is what's the percentile ranking? What's the area that we're working with? For this example, it's 0.95 because I had the 95th percentile. Then it wants to know the mean, which is 48. And then it wants to know the standard deviation, which is 2.2. Notice I put commas in between all 3 of those values. You're going to do that in your calculator. And I get 51.6. Depending on the word problem, it might make sense to round to the nearest whole number. In this case, we can leave it as a decimal. So the braking distance that represents the 95th percentile would be 51.6 meters. That means 95% of the time you can expect it to take less than 51.6 meters before that Cadillac is going to come to a complete stop. So that's part A. Let's move on to part B, where it's asking about what's the braking distance for the top 1%. So I'm going to erase some of this stuff here if it will let me. Almost got it. Oh, I should have paused that. Well, it's too late now. Okay. There's some important things here. So again, we have another percentage. We have a 1%, but we have to be very careful with the language. It's the top 1%. If you are in the top 1% of something, that word top, you're going to think complement. It really means 100%, the complement, basically, of 1%. It really means you're in the 99th percentile. The top 1% means 99% is below you. So we call that the 99th percentile. So that's what you've got to do first. Because of that word top, you have to think complement and use the complement. So now what I have is I'm going to do inverse norm. Now I want the 99th percentile. So 0.99, 48 meters is my mean, 2.2. is my standard deviation. Your calculator is going backwards on that original z-score formula, and it's going to get back to the real life value of 53.1 if I round to the nearest tenth. So 53.1 meters is in the top 1%. That means 99% of all Cadillac Escalades will stop sooner than 53.1 meters. If you see the word bottom 1%, Well, that's what the 1 percentile means. So the word bottom is not necessary when you're using percentile ranking, because that's what, if you're in the first percentile, that means you're in the bottom 1%. So it's only where the word top 1% that you have to do this complement thing. So the last problem we're going to look at is what's the braking distance that goes with the first quartile. So let me erase some of this writing for the last one. Okay, so now we're dealing with the first quartile. We know what quartiles are. You did those in the first module when you were dealing with the 5-number summary and the box and whisker plot. If you remember that key word quart in quartile, the first quartile was Q1. That represented the 25th percentile. So I would do inverse norm for this problem. If I want the first quartile, I would put 0.25. My mean, again, is 48 meters. My standard deviation, 2.2. And I get 46.5 meters. So just to fill them all in, since I erased them as I went, the 95th percentile, the braking distance was 51.6 meters. The top 1%, which is really the 99th percentile, was 53.1 meters. And the first quartile is represented by the braking distance of 46.5 meters. When you're doing these problems where you're going backwards, where you start with a percentile and you want to get back to the real life distance, make sure you put your units, meters, dollars, pounds, whatever it is you're talking about.